All right, welcome to the exciting second half of this, right? So we've had this collision, and we want to know how much energy is lost, right? So this is 0.145 kilograms, and it's going 0.150, right? And these guys are colliding head on, right? Here's this other glider, a little bit bigger, right? And it's going, let's see, 0.430, right? These guys collide head on, and we know that they stick together, and they're actually moving this way at this velocity, right? So they're going negative, so we'll make that negative, right? Negative 0.2414 meters per second, right? And this mass here is 0.145 plus 0.301, right? I think we could dare to add that, couldn't we? 0.145 plus 0.301 is 0.446, right? So what we're going to do is we're just going to add up the kinetic energy here. So 1/2 0.145 times 0.15 squared plus 1/2 0.301 times 0.43 squared, right? So let's do that. I'm just going to do that in one swell whoop. 0.5 times 0.145 times 0.15 squared plus 0.5 times 0.301 times 0.43 squared. So this is our kinetic energy before is 0, not a lot of energy, 0.29457 joules. So that's the KE before, right? And then the kinetic energy after is going to be 1/2 0.446. That's the combined mass of that, right? Times this whole number here, unrounded, right? So 0.24143 squared. And it's important that you not round that number, just because it's very sensitive, because it's squared. Let's see if I can find that number here. Okay, this guy squared. All right. And I'm getting that energy is 0.0129988 or something like that, right? And that's the kinetic energy after. And of course, this minus this, right, is equal to the change in kinetic energy. So I'm just going to take that number and subtract this number. And I get that the energy lost is 0. So literally, I'm going to go this number minus this number is equal to 0.0164598, which that would be, with 3 sig figs, 0.0165 joules. And that's what's lost. That's the sound of that massive collision.